Hi, this is Paul Palmer. So, following yesterday's broadcast, I was asked if I could talk about cross-contamination. So this is Paul Palmer, and we're live again. And today we're going to be discussing pharmaceutical cross-contamination. So it will be really a bit of an overview because, to be honest, the options for cross-contamination are quite significant, and the control of it. So when anybody does come on and ask specific questions, well, I'll cover that specific area. But initially, what I want to talk about is really defining what I mean by cross-contamination. So as you can see on the background, we've got multiple dosage forms, and we've got multiple products for each dosage form. Actually, I think we've only got one for the capsules because the caplets and then the tablets. Yeah, we've only got one type of capsule there. But I wanted to put that background on purpose to make sure it was clear that what we're talking about today is cross-contamination of specific products. So one product ending up in a different place. So, for example, when I worked for Novartis, we had let me think. I can't think which line we had actually. So we were packaging hormones. So it was high potency product. So we had strict controls on the way that we were actually manufacturing, because we had to make sure that we didn't contaminate the rest of the factory. So that's what the first area for potential cross-contamination. So how did we do that? Well, we used the actual facility, the design of the facility, to prevent cross-contamination between that line and other lines. So we put separation out. So the actual high potency line was completely separate from the rest of the lines, whereas in other areas we just had barriers in between. But let's stick with one for a start. So this high potency product, the hormonal product, you probably know from people that do take the pill, any of you that might be involved, actually know that the pill has 21 days of one product and then 7 days of another product. Now, for it to work properly, you have to use them in the right order. So what do they need? Well, it gives you 1, 2, 3, 4, 5, up to 28 on the actual foil. So it's telling you which ones to use. So you don't want what you would say cross-contamination or incorrect fill of one product in the wrong pocket. So we had to have image recognition. So we had visual cameras on the line confirming that the right product, the right strength. So it was progesterone, estrogen combination in the 21 pockets. And I think it was estrogen only, but maybe a different strength in the other 7. Maybe in progesterone. I can't remember now off the top of my head. It depended on the specific format of product that we were actually manufacturing. Okay, so how did we avoid the cross-contamination? Well, of course, we had separate hoppers, and we had second checks to make sure when it was filled from the warehouse, the individual products that had been manufactured independently of each other and were labeled with separate colors to avoid crossover when you're actually filling the hoppers. The hoppers were color-coded to match the manufacturing color codes. And then on the actual line itself, because the 2 tablets were different colors, we used a vision-based system to actually demonstrate that the right tablet was in the right pocket. So you've got all this going on, but we still got complaints. So why did we get complaints? Well, sometimes one of the tablets may jump out of a pocket just before it was sealed, just before the foil was sealed. So what we ended up doing was adding extra plastic, basically plastic. I can't think what the proper name was. The material that was used was the plastic, and it was pushing it down together so that you didn't get the tablets popping out. And then I think we ended up with a person in there watching as it went through, as well as the vision-based system, and they would, because the line was running quite fast, the person would not really be fast enough to be able to check, yes, they're all in the right place. So all they were checking was see if there's any popped up and then fixing it with a gloved hand, of course, if it was going through. I seem to remember we had a reject system instead of just doing a straight fix if one got through that they couldn't catch quickly enough. So they could just put I don't think they could put a black line on it because we had the perspex. That's what I was trying to think of. The plastic, it was perspex. So there was perspex over the top to stop it once it was together, jumping back out of the pocket. And you had a solid underside to stop the web falling downwards. And that way we actually ensured that we had the correct tablets in the correct pockets, so we didn't have cross-contamination within the same product. So now, what's next? Well, cross-contamination between lines is a good one, or cross-contamination on a single line. So let's stick with primary packaging again, rather than manufacture, because we're not going to talk about the manufacturer cross-contamination today, because that's quite significantly more time to talk about. And to be honest, I don't know whether you're all going to get fed up if I talk about everything all in one go and just turn me off. So I'm going to stick to it in short bursts, as we've been doing previously. So we've looked now at cross-contamination of a specific product, between products on a specific one line. Okay. So what's the first thing you want to think about? Well, you want to think about one product to the next. Is it the same size? Is it the same color? And if you can avoid it, you don't want to have same size, same color sequentially. Now, I say if you can avoid it, it's usually avoidable because there's different colors of product. So you'd start by taking out your change parts, but then you want to make sure you've done a risk assessment to confirm where the actual product itself, or the tablet, may actually get trapped within the machine. If you've got a location that's regularly trapped, then make sure that's on your line clearance instructions, preferably with some imagery as a checklist that you can then use to make sure that you're not going to get one batch crossing over into the next. Now, bear in mind that it's not just the change parts you're going to look at. And also, if at some point in the future you find out you have had cross-contamination from one batch to the next, well, you can then do a root cause analysis and see where could it have come from? Where could it be trapped? And sometimes it's actually breaking down the machine and finding the product that's actually still left. Now, I went previously, sometime recently, to a site where they had a different color label that was in use. So they were sticking a label on top rather than printing onto the foil. And I could see inside the sealed machine that there was a different colored label on the base. Well, you can have the same thing with a tablet. Usually they talk about it being below the level of the web. But just because it's below the level of the web doesn't mean something can't go wrong. So, for example, if it's below the level of the web and something else can drop on it, maybe another tablet, maybe a capsule, maybe something else, something knocks it, potentially that can bounce back up onto the line. Extremely unlikely, but you never know until something goes wrong that you've captured everything. So when you're doing your risk assessments, you always want to make sure that you cover as many details as you can. So I particularly like using a brainstorming session first. So these are the potential areas that you could get the cross-contamination coming over from. And we're looking, just at the moment, we're just looking at changing from one line between product to product or batch to batch. Not really batch to batch of the same product, different products. So where's the potential places that the product could get stuck? Now, could be a tablet, could be a capsule, could be a caplet. Probably not much else. So you're putting it into the primary packaging and you think, well, if it's going from there and it flicks upwards, where can it get held? Where can it stop? Where can it get stuck? And you make sure you're always checking that location. Now, the way to really do it in the first place is to design it in. FMEA, good tool for risk assessment. And I would do the FMEA after you've done the brainstorm. Yes. So FMEA is a good tool when you're looking at a process, Nazif, and when you want to list out all the different steps in the process, all the things that could go wrong. So yes, I like FMEA from a risk assessment. I was talking about that. If you look up Jan Kugel, Nazif, you'll see that I've done one for risk assessments on there. But to be honest, it was quite limited in scope. I was just talking about which tools you select and what for. I think it was last Wednesday, maybe. So Jan Yan Kugel, Kugel, and if you look for his name and my name together, then we did a webinar on it. It was an hour, so you might find that useful. I will be talking about risk assessment here on my channel in the future as well, though. So you're welcome to wait, because I will go into more details. Today we're just talking about cross-contamination. I'm not going to be going into more detail on risk assessments today. So you're doing your risk assessment. You've identified your potential locations that any tablet, capsule, or other product that you're actually packaging could get trapped. But the best way to do it is before you even start manufacturing, that you you're welcome, Nazif. Before you start manufacturing, that you design your process to not have places to trap the tablets in the first place. And what you'll be looking for is a smooth surface with no gaps. Often it's steel, sometimes it's perspex. And then when you're doing a changeover, you're pulling pieces out and you're putting them back in, and it's still sealed again. Stainless steel is often the best option to maintain integrity on the actual manufacturing process. But of course, if you want to look through, you're probably going to want to use perspex. So where were we up to? Well, we're talking about the option for avoiding the cross-contamination when you're going from batch to batch. Now, some people like to actually just change the minimum when you're going batch to batch. But my preference actually is to break down the machine in more detail and more extensively, so that you've actually got bare bones, as I would call it. So you're taking off your foil, even though it's going to be used on the next one. You're taking off any of the specific fixings, any of the clamps that are there for both, even whether they're both or just one of the products. You're taking off the line, and you're actually making sure, usually with a vacuum cleaner, but make sure you've got a controlled. Make sure you've got your Sorry a minute. Make sure you've got your vacuum cleaner set up so that it will capture all waste. You don't want anything kicking out into the back. So usually the vortex approach is the best one, but then you want filters on the exit for the air as well, down to probably 0.2 micron usually, which means you need a big filter. Okay, so let's get back to the topic. So we're vacuuming out the any previous product from any nooks and crannies that you can see. Now, if you can see something coming out or you hear it, so the time that you'll know you've actually captured something, you'll hear. Okay, maybe that's not a very good impression, but that's how it sounds to me. It sort of comes out, it clicks, and then as it goes down the tube, it goes, it rattles down the tube. Yeah, it doesn't go, that's more of a tune, isn't it? So it goes down the tube, and you know you've captured something. So next time you come back, you know that's an area that you need to identify for future cleaning. Thanks, Preetham. Glad to see that you're here watching. So you've broken it all down completely, and the likelihood is that when you've broken it down, you're going to capture all areas that your product could potentially get trapped. But unfortunately, you'll still find that things bounce off into areas that you don't expect. They go into the workings of I didn't realize I could do that. Okay, well, I've just worked out how to pop the messages up onto the screen. Okay. I know how to do that next time now. Okay, so the product might, for example, go into the workings of a rotary motor. So how do you avoid that? Well, you put the rotary motor on the outside so that it's not in direct contact, or it's not within the confines of the controlled area, the controlled environment of your actual machine. Now, this is a really important consideration. It's always about design. If you've had a problem with cross contamination, with the product being in the wrong place, a batch going from one to the next, and it's no longer it's been contaminated. You've got a rogue. You've got a rogue in your batch. It's probably the best. It's probably best to use the correct terminology. I'm just trying to keep it so that it's understandable for everybody. So you've got a rogue in your batch. It goes through, and you know that you're going to have to do 100% inspection because you've found the source, you've seen it drop down, 100% inspection, take it out. But you don't want to be doing that regularly. So you don't blame somebody for not spotting it as it went through. You look for preventative action. So what's preventative action? Well, it's a mechanism for ensuring it can't happen again. The other terminology that I used the other day, poka-yoke, Pokeyoke. If you look that up, that's a Japanese term for zero defects, zero defects. So you actually engineer out any failures. So every potential item on the list from your FMEA, Nazif, you actually make sure that you engineer out the possibility of that happening. And you prove it, you test it, you do your validation, you do your verification of your line to make sure it can't happen. If it can't happen, then you're engineering in your controls in your process to avoid cross-contamination. Unfortunately, my phone is whistling at me because I'm not answering it. So I'm going to have to just turn that down to 0. There we go. That should do it. Okay, so what's next? Well, the next thing to think about is line to line. Now, the planners need to be involved at this one, because if you've got two products that are both white tablets, okay, maybe they've got a different letter on them, but think about it really. How many people off the street that are getting a product from the pharmacy on prescription are going to say, right, that's my white product with a P on it. That's my white product. Oh, it's got a Z on it, so it's not my product. I don't think they're going to look. And even if they do, they'll just say, oh, yeah, it's in the right packet and the box is right, so it must be the right thing. So it's up to us in the pharmaceutical industry to make sure we've got the controls right. So let's think about an example. So we've got a 500 milligram paracetamol tablet. A paracetamol tablet, acetaminophen, if you're in the US, is easy to use as an example because most people know what it is. Right, and the next line, so you've got a line going here with the paracetamol that's filling, and you've got a next line parallel with another product filling. Okay, so let's say the other product is aspirin, and the people that are taking paracetamol are taking it because they're allergic to aspirin, or vice versa. They could be allergic to the paracetamol. They might have asthma, and it's causing them problems. It's increasing their risk. Either way, you've got these two lines running side by side. And the tablets themselves are approximately the same diameter. They're both round, and they've got an A on the aspirin, and they've got a P on the paracetamol. And they've both got a break line down the middle, and you've got 600 milligrams in your aspirin, and you've got 500 milligrams in your paracetamol. What are we going to do? First thing, run your lines opposite direction. Now, why do you want to do that? Well, you'd want to make sure that the two hoppers are not next to each other. So you can accidentally or inadvertently, or however you want to put it, put the wrong product into the hopper. Make sure you've got a plastic screen between. Don't just do spatial separation. I know it's allowed. And I know you can do a short barrier, but do it floor to ceiling, full length. More than the length of your line. So, hopper to hopper. So what's the easiest way? What's the first option for making sure that you cannot accidentally put it in the wrong one just because you've got to the end of the wrong line? Put it at the other end. So you turn your lines round so that one goes that way and one goes that way. I know it means that you need to have two feeds, one feed, one exit, but it's a higher risk of putting the wrong product into the blister than it is mixing up pallets, mixing up finished pallets. Well, you've already put the product into the primary packaging. You've already labeled it with a product name, with the strength, and all the other essential information. And hopefully at the end of the line, you've got your robot that's doing your filling into the shippers onto the pallet for you. So you've actually got no manual intervention that's potentially going to put it in the wrong place. So first thing, opposite directions. So you're keeping your incoming and your incoming separate. You've got your outgoing, your finished product, next to your incoming, your bulk product that's going to be primary packed. And actually, we're talking about secondary packaging as well. I wish I could remember the name of that line we were using. I'm sure it began with N. But anyway, the first thing we're doing, opposite directions. The second thing we're doing, full perspex or full wall in between, fixed. We've got our machines fixed to the floor. They're not moving. We've got different supply at each side. What's next? Well, what I would suggest next is the way that you fill your hopper for one of them is a different shape to the way you fill the one for the other. So if you're bringing in your aspirin and maybe you're doing a suction tube into the hopper, the suction tube aperture into your aspirin vessel wants to be a different design to the one for your paracetamol vessel. And I know the purchasing guys won't want to do that. I know purchasing will want to have identical ones so that they crossover, so they don't have to buy more change parts and have different stock in. But we're talking about people. Isn't it more important that we actually focus on saving people? Isn't it more important that we focus on safety for the patient than maybe saving, I don't know, maybe it might even be 10,000. But if you can spend the 10,000 and you save 10 people's lives every year, or one person in 5 years, I still think it's worth it. And to be honest, when you set up, you're still going to be buying the two hoppers anyway. So why not? So maybe you're taking the first one on vacuum from the top and the other one's feed from the bottom. The other option you've got, of course, is your feed from above. If you're feeding from above, though, then to be honest, that's a longer story because there's more complexity in it and there's more things to think about because, of course, your chute's coming straight down, but above it, you've got one here and one here. Oh, I don't know why that happened. You can't see my hands. So you've got one here and one here, other sides of the room, and you've got a different risk because you've got no separator in between. So you want to make sure you've got the separator and maybe you've got a separate feed from the manufacturing suite. Okay, so let's continue with the downstairs with the primary and secondary packaging. So what else can you do to make sure these two lines are the same line? They're running in opposite direction. The hoppers are different, both sides. Okay, so that's good. What can we do on the line itself? Well, we can make sure that we've got the design such that it has to verify the letter or the code on the tablet with a vision-based system. Okay, if we're embossing it, we probably can't do that. So what do we do instead? Inkjet one, emboss the other. So now we've got two products that did look very similar. but no longer do. So when we put our product into the hopper, our vision-based system, as the tablets are rolling, can see it. So we've designed out the risk. We've made a change to the product. We've separated the lines. We've moved the lines to opposite ends. The system that we're using to bring the actual product, the primary drug product, into the packaging machine is different. What else can we do? Well, we need to train the people, don't we? What about in the warehouse? Because the storage we're going to have, primary packaging storage in bulk, is going to have some controls as well. Where products are potentially hazardous to each other, put spatial separation. Use your ERP system to say, right, they're not allowed to go next to each other. In fact, maybe they're not allowed to go within 3 bays of each other. They're probably going to be on the floor. And you want a coloured product in between, maybe. Okay, so you want to set what goes there, what goes there, what goes there. And then when they pick up the drums, well, that's another opportunity, isn't it? How are you actually transporting the drums? You've got a drum carrier on one. What can you use as the other one? What's the alternative? Okay, so one of them's a round drum and the other one's a square drum. The square drum, maybe that's not realistic. I've never seen one. But a square hopper is. A square hopper on wheels with an output at the bottom that goes straight in and gets vacuumed in. Well, that's where our paracetamol is. And our aspirin is in the round drum that feeds straight in. So we've engineered out potential cross-contamination of the product because you identify it differently. We've designed the lines themselves so that you can't accidentally cross them over. You can't accidentally put one onto the other line. We've switched them to opposite ends, so they're not even going down the same corridor. We've got, I think I said the vision-based system, looking at the identity. And we've got people that are trained and they understand this is what it's supposed to look like. So in order to prevent cross-contamination from those 2 lines, we've got all those different options that we can use. Now, they're just examples, but you can use the same philosophy for anything. Yes, we talked about primary packaging line, but what about finished products? We've got finished products. We've got some that are in that are quarantined, not released yet, and we've got some that are released. We've got them both in the warehouse. Now, the quarantine products, maybe they're packaged in one way. Maybe we're not actually going to repackage them going from quarantine to release. But what if the release step was before you do your cartoning operation? So you've got all of your blisters in bulk. I know this is probably unlikely because most times now we go straight down the line. But let's just play devil's advocate. This is an option. So we've got our blisters in bulk. And those bulks are fed into the secondary packaging machine. On the secondary packaging machine, they're then going to the cartons. But they're not allowed to do that until they're already released. So we've prevented accidental picking of the wrong product, of the quarantine product versus the release product. What else could we do? Well, we changed the outer labeling. So internal labeling, external labeling, different barcodes, different check digit, different naming system. Internally, you might want to use a certain reference, and externally, you label it according to the packaging spec. There's always a way of separating. You might have the same rectangular box, but if you pack it in a different way, with different nomenclature on it, you're not going to be able to ship it. I know this changes the process, but that's the only way you take out the potential defects. That's the only way you avoid cross-contamination. Now, we're up to half an hour again, and I think half an hour of you listening to me talking with, to be honest, nothing to really read or look at other than these nice little tablets behind me. Hopefully you found that interesting. And I'm open to suggestions for what we talk about tomorrow. So if anybody's got something specific that they'd like me to talk about tomorrow, then you can either comment on this or you can send me a message. And I will, of course, read any comments that you post. I am getting quite a lot of comments at the moment, so you might want to send me a message if there's something specific that you'd like to talk about. If nobody comes up with something, I'm probably going to talk about seed integrity method validation, because I feel that that's an area that is quite often low on people's priority. And I have done the validation myself personally of seed integrity methods, different methods and different types of packs. So it could be an interesting discussion. Hopefully you'll enjoy it. If somebody else comes up with something else that they prefer, then I'll do that, and I'll do the seed integrity validation on what day is it today? It's Wednesday, isn't it? So I'll probably do the seed integrity on Thursday, unless somebody has a really strong need for me to talk about something else. Then I'll put it back to Friday. Okay, so that's it for me for today. I hope you've enjoyed the session today. Thank you for the comments, and I'll talk to you again soon. It's Paul Palmer, if I didn't say already. I think I did, didn't I?